In the first class, we established the concept why we solve equation. On this second part, we shall be talking about something very important. So we'll name this basis of equation. Now, for me to explain this basis, we have to use something to explain it. In this side, we have two sides. There are two sides. We call this side 1 and side 2. Right? So, when something is crossing from side 1 to side 2, it takes the opposite. Write this thing down. Note number 1. When something is crossing from side 1 to side 2, when a sign is crossing from side 1 to side 2, it takes the opposite. And side 1 and side 2 are separated by an equality sign. So if minus is crossing from side 1, when it gets to side 2, it becomes what? Plus, because plus is the opposite of minus, is it not? Okay, so if division or multiplication is crossing from side 1, when it gets to side 2, it becomes division, right? Okay. If square, okay, let's say something like yes, if square is raised to power 2 is crossing from side 1, when it gets to side 2, it becomes square root, right? So when a sign is crossing from side 1 to side 2, it takes the opposite. Now, let us give some few examples to practicalize this. If we have something like x plus 2 equal to 3, how do we solve this equation? We are looking for x, right? And if we are looking for x, all we need to do is to remove everything that are connected to x from this side, so that x will be standing alone, is it not? So when we remove anything that is connected to x, we have the solution for x, because x will now be equal to a number. So what happens is that x, what are we removing? We are removing plus 2, is it not? And when plus, according to this example, when plus is crossing to the other side, it becomes what? Minus. Likewise, when minus is crossing to the other side, it becomes plus. So when plus 2 is crossing to the other side, it becomes what? 3 minus 2. And x will therefore be 3 minus 2 is equal to 1. Very, very easy. Alright, so let us take another example from here, because okay, let us take another example to illustrate square and square root. Let us say something, we have example like p square. An example like p square is equal to 4. Then you say find p. You can't say p square is equal to the answer, because there is something connected to p. Until p is standing alone, then you have an answer for p. So what do? We try to remove this square root to the other side. And when you look at this rule, when square root is going to the other side, when square is going to the other side, it becomes square root. So from this we have p will be equal to the square root of 4. So that P will be equal to square root of 4 is the same thing as 2, right? Alright. So what if we have divide? Now let's take a look at this example and we'll continue. Alright, so another example is if we have 2x is equal to 10, then look for x. Now you discover that x is not standing alone, and since x is not standing alone, there is no a solution for this equation yet. Until we make x stand alone, then there is a solution. And how do you make x stand alone? You displace anything that is connected to x to the other side. So when we are moving 2 to the other side so that x will stand alone, we discover that 2 is connected to x by multiplication, right? Because 2x means 2 times x. So to remove 2 from this side so that x will be standing alone, we discover that since 2 is connected with multiplication, when 2 is going to the other side, what happens? It becomes what? Division. Is it not? Because division is the opposite of multiplication. So x will be equal to 10. Now this 2 that is in this side, when it goes to the other side, it will now divide what? 10. And x will now be equal to 2 over 10 is equal to 5. That is the solution. Thank you very much. God bless you. In the next class, we'll be looking at some kind of more complicated solution, bringing plus, minus, division, square root together, and you discover that everything becomes very easy. Make sure you like and subscribe. God bless you. Thank you.